will tell you more about gazebo simulation environment, and we will go deeper in our skill. So first of all, I would like to remind you about the schedule. Today, day for lesson and practice, and tomorrow will be our final day. And this final day, you will perform in the final task, which we share it with you in the end of day. So, and today will be more practice, more advanced level in gazebo environment. Feel free to ask us about it, and don't forget to perform your homework, because it's very important. It helps you to train your skill, and also it helps us to find your not strong sides, to find your mirror, to find your errors or another difficulties, and we can solve it together if you will perform the homework, of course. So also yesterday we have more technical questions, and today it will continue. So feel free to ask us about it, or in our common group, or personally to Artem Batalov, Yulia, and Timofey. We will help you, of course. So, okay, I think we can start our classes, and let's welcome Yulia and Timofey. Guys, connected?
Hi.
Great. Okay, I wish you good luck, and see you in our evening briefing after lesson. Okay, Yulia, Timofey, welcome.
Okay, good morning. So now I think we should start from our homework. I got some results from some peoples. It is Jacques and Bruno from Brazil. They sent me full homework and flip, of course. So I think some people send their homework to Svetlana and Timofey. We will make your schedule with your marks some later. And now I would like ask somebody of you explain how you make a flip, if you understand how it works. Maybe Jacques, or maybe Bruno or Mohammed, who understand how it works.
And Stotam, of course. Guys, don't worry. You can share your experience and share it, your results. And please, I think it will be really interesting if you describe or explain how it works for other participants, and how you perform your task. Okay, it can be Stotam, Bruno, or Jacques.
I saw your homework. It works good. So I will send it to general chat now, and it will be great if you tell everybody how it works. Totem made double flip.
Hello.
Hello.
Yeah, I'm Stotam. Can I share the screen?
Yes, of course.
Okay.
Be a star, be a hero.
Is it visible?
Mm, just one. Yes, yes, great. Perfect.
Okay. This is my code for the single flip. This is the code defined the function for flip, and it has 20 and thirst 0.9 per and
Okay. But it's seems with some delay.
yeah,
Maybe
that was for the single flip.
yeah, maybe you explain how it works and show us your video. I think it will be required. It takes minimum characteristics and it will be without delay. Maybe I'm not sure, of course, but maybe it takes minimum resources if we compare it with simulation.
This is for the double flip. Okay, that was all.
Yeah, okay. We have seen a video on Telegram. Okay, thank you, Stota. Yeah, who would like to explain the code, guys? Oh, it was difficult, yeah, difficult task. Okay, Yulia Timofey, could you comment it?
Yes, wait a second. Can you display the code?
Just a moment. Mustafa want to comment it. Maybe. Okay, guys.
Yeah, go ahead, Mustafa. I would like to hear your comment.
Okay. So I think I'll share my screen. Hello, everyone.
Hello, hello.
Can you see my screen?
Yeah, yeah.
Okay, great. So I'll just be explaining the flip part, because I think everyone gets the navigation part from Timofey and Yulia explaining them yesterday. Thank you, by the way, for that. So basically, the flip part, which is in my code, this small part, it's a function. There was two ways for the drone to flip, which is a roll flip or a pitch flip. I used a roll flip. A roll is basically a flip around a specific axis. So what the function does, it does a couple of things. First thing, it saves the initial position, the initial telemetry of the drone, for it to be able to use it after the flip at some point. I'll be coming back to this in the end. First, it gives the drone a thrust or an initial thrust to be able to do this the flip without falling to the ground. Then you have to increase the rate for a specific orientation, whether it's the roll or the pitch. So using the roll flip, I had to increase the roll rate, and experimenting with different thrusts. 4.4 worked for me. I think you can experiment with different values for thrust to see if it works or not. The best way to do this is using the dynamics of the drone, but this is another way to do it, which is trial and error. So basically, this is the part that does the flip. It starts to increase after increasing the rate for the roll and the thrust. It starts to the drone starts to flip. This functions starts monitoring the angle for the drone. The more it increases, it compares the actual angle for the drone with a value, preset value. That value, I had to experiment with that value as well, which is a different angle. In my case, it was more than a quarter of a circle, which is around, I don't know, 100 something degrees. So it keeps comparing the angle. When it reaches that angle, let's say a quarter of a circle, it will stop flipping. Then it will use the initial position that we talked about earlier. It will use that initial position to return to. So when you reach a specific angle, it will come to a stop concerning the flip and will start to stabilize. There will be two ways to do it. Is there a way to annotate in this thing? Okay. Let's say the drone reached 180 degrees. I don't have a way to annotate on my screen, unfortunately, but I will try to explain it. if you reach halfway of the flip, there's two ways to stabilize, whether it's returning backwards or continuing the flip to stabilize, and that's what the drone does. Continuing the flip is the best way because the drone already has inertia in that direction, so it continues the flip and stabilizes in that direction. So that's basically how my flip works, and that was the example provided in the code snippets, and that's what I used. I think that's about it. Are there any questions? Can anyone hear me?
Thank you for your comments. And yes, guys, if you have any questions, Mustafa will answer it.
Okay, thank you very much.
So, okay. If nobody have questions, thank you so much, Mustafa. It's really cool you understand how it works and explain it to everyone. Thank you. So now Timothy will tell you about one important thing and one important service in this code. It is set position, and we can use in this code only set position. And I think Timothy now tell you why.
Yes, sure. I will tell you why. Can you share us share your screen with us?
Yes, one moment.
Maybe with code for the flip.
Oh, I think Mustafa can share his screen with his code. It was
Yes.
It was good, really. Mustafa, can you share your screen again, please?
I did see my screen. Can you see my screen?
Yes.
Okay.
Yeah. So here I can see your screen, and for you guys who didn't use set position before, you can see the line 51. It says set position x equals start x, y equals start y, and z equals start z. Then yaw equals start yaw, which is it looks pretty similar to navigate, as you could notice. But this set position is missing one important thing: is it is speed. So in set position we do not set speed. It just doesn't have such an argument. Why would we even use that? Well, for example, if we want to travel to a particular point at the speed that is convenient for the drone. For example, if the point is pretty near to your drone, like 10 centimeters from the drone, from where the drone is now, you don't want to calculate the timings, the speed for travel. You just want to tell the drone go to this point, and the drone will move to this position pretty quickly. But if the distance between the drone and the point where it is moving is too high, like it's too many centimeters, maybe 1 meter or 2 meters, then the drone will go too fast, and it's not safe to use set position in this case. So you need to make sure that every step when you use set position, that step is quite small, so you don't have to travel vast distances. And why and how do we use it in our code? It is very useful when, for example, you have a function that calculates the drone's position, the desired drone position, several times a second. Like maybe 10 times or even more, 20 times per second. And you can control the speed of the drone, not by passing the speed parameters to set position, but by changing the position over time. So you have a more general control over speed. You just tell the drone like 10 times a second where to go, and the drone will follow your command. You can find a code that uses set position just that way in the code snippets article, and I recommend you checking out the code for circular movement. Mustafa, can you open the documentation for us to show this article, and I will show you where to find this code, and later on, maybe today after this lesson, you could check it out yourself and try to make a circular movement with your drone. So there has to be a code. Yeah, just Control F and write circle. Yeah, circle a path. So here you can see this code snippet contains a while loop. Of course, you can wrap this whole piece of code into a function, which I recommend you do. And this function will have while loop, so while not ROSPy is shut down. You remember I told you before. First, it calculates some variables for getting current angle on this circle, then calculates x and y in particular moment of time, and then you have set position where you provide x equals x and y equals y, and z equals start z, which means that you do not change z. So x is calculated by the sine function over from time, and y is actually cosine function. And how do you alter the speed? Well, you alter the speed by the angle variable, which is actually time. So it increases as time increases, and you can slow down or speed up the change of position by multiplying it by the speed constant, which is given in the beginning of the code. So basically, this code is just for your self-learning, and after we will not check this out today, but you can check out yourselves and try to make a function so you can call it multiple times in your code. All right, this is basically what set position is. Of course, you can provide different frame ID to set position, and the whole list of arguments is available in the article symbol of board. You can find it on to the left side on this site. Can you find the article symbol of board? Yeah, and find set position here. So the list of arguments that are available here is XYZ, which is coordinates, then yaw, which is calculated in radians. So you provide radians to this argument, like pi radians or pi over 2, and so on. Yaw rate, which is the angular speed for the change of yaw. Auto arm, of course, you can even take off with that position, which I do not recommend. And the frame ID. So you know how to use it already. You can use any frame ID available for navigate. And here are some examples for set position. I don't think they are very useful because, for example, if you set position x0, y0, z3 from body, it means that the drone will fly as crazy, 3 meters high, and it may hit something while taking off. So I do not recommend you copying and pasting these code snippets from here. Just use set position and in places where it is necessary to. We needed to explain you this service because you used it in your homework, and you can experiment with some functions like sinus, sine, cosine, and some other functions that you want to calculate, for example, of time, and set the coordinates to the drone by set position. So this is it about set position. Julia, I think you can continue with the next topic. Thank you for this screen share.
Thank you, Timofey, so much. And it was really important to understand because it is can be part of our final task. Svetlana, can you share our final task, please?
Yes, sure.
Oh, thank you so much. Yes, it's okay. Yesterday I said you will have one competition day, and what about task for this competition day? It's first. It will tomorrow in first part of our. If in first part of our lesson, and you will have only 1 hour for programming special task. And okay, what about it? We will study today how to create some objects in Gazebo simulator and how use it. So you should understand it very good because tomorrow it will the main part of your task and competition. The first one, you should create 3 objects. It is takeoff zone and landing cube and ladder with 3 levels. After it, you should write a program for drone for autonomous flight, and drone need to take off from takeoff zone and fly through all levels of ladder, and after it land to the cube. But if you was very good students, and many of you was, you can write flip program for flip, or you can take it from your homework, and after ladder you can make flip and then land to landing box. It will give you more points. So that's what about your task for tomorrow competitions, and be a good student for today, and you will complete it tomorrow very good, I think. So if you have any question, you can ask me now. So nobody have questions about final task? Okay, very good. Then let's start our today's lesson. I will share my screen. Can you see it?
Yeah, we see it. Great.
Okay. So yesterday we used some services and topics but what is mean services and topics? It is a part of a robotic operation system what we use in our drones to control all parts of our drone. Services allow us to make one actions or ask drone to do something. For example, we can ask drone fly to point with service. We can ask drone give the telemetry with service, and it is like services allow us to make some action one time and maybe get response, or if we don't need it, just make some actions. Topics, it is like maybe chats where in other programs or part of drones can send messages.
Telegram channel.
Like a Telegram channel, yes. So it can be some information from camera, and program what works with camera just send some message in topics all time, and it doesn't matter for camera read it somebody or not. I think I will show you how it works, and you can see it in your gazebo too. We need to open our terminal and simulator. The first of all, I think we can see all topics. How to make it? I can write ROS topic echo and press tab. It asks me want I show all topics or not. Yes, and I press yes, and it showed all topics. Okay, it looks very strange. Yes, I will make it. Yes. Okay, I can try it. It doesn't matter. So what about topics? We have a lot chats where some part of drones or some programs send information all times. For example, let's try to subscribe for one of topics. For example, let's subscribe to Mavros state, for example. And now we can see a lot messages what sent it to our topic or maybe our chat, and we can see information about our drones there. For example, frame and is it connected or not? What mean connected? When we use Raspberry Pi in our drone, we connect it with PixRacer or PixHawk with flight controller through USB, and if it is connected with flight controller, if Raspberry connected with flight controller, the status will true. If not, it will false, and it means drone can't fly under Aruka map in afternoons. So the next one, it is armed status. Now our drone placed on the ground, and it is disarmed. So the status is false. And another parameters. So let's try to do something with our drone, and these parameters will change it. For example, we can take off. I will just open new terminal.
Take off using.
Okay.
You write here commander icon.
So
this is another way to take off easily.
Thank you, Timothy. Very good feature. You can use commander takeoff there. So now our drone take off, and parameters in our topic was changed. Connected true, and now, for example, armed true. Mode was changed to after takeoff, and system status was changed to. So that's what about topics. I can stop topics with Control C points. We can check another topic, for example. For example, topic with rangefinder, and in this topic we can see measurement from our rangefinder. Somebody turn on his microphone. Ari, I think it is your microphone. Okay, thank you. So, topics with rangefinder data. Now we can see how range change in real time, and our drone take off on 2.6 meters up, and we can see it in simulator. So now rangefinder placed on this drone in bottom part, and we can see measurement from rangefinder in this topic, and we can use it in our code too. We can make subscriber on this topic and use measurement from the sensor for our mission, for example. So next one, it is ROS services. ROS services, it's like some commands what we can use to control our drone or our system or some another part of program. What about services? What we have? I think you know this service and you used it, get telemetry, and you know land service, and I think you know let's set effect service, and maybe you know this service too, navigate. So that is all services what you can use to control your drone. And wait, turn off your microphone, please. Wait, please turn off your microphone. Sveta, can you mute new people's? Okay, thank you. So that is a list of all services in our system, and you can use any of it in your program and in Python program, or you can use it in terminal too. For example, yesterday we used ROS service get telemetry service or navigate. You just should to write a service call, and after it service name, and press tab, and system will write some parameters for this service, and you can set up some parameters for it. For example, I want to get telemetry in Aruka map. There, I just write this command, and I get only one answer for it. If in topics we can get a lot of information sometimes per second, then there we can get information only one time. And now I got coordinates and speeds and some angles and voltage. So any of these topics you can use or from terminal or from your code. I think that's all about services and topics. So now I would like to you check this material in your simulators. So please try to get some information from any topic and from any, and make some action with any services in your simulator, and send photo to the chat, please. It's task for everybody, and you have 5 minutes for it. I think it will enough. So please subscribe to any topic and please make a screenshot and send it to the chat. And after it, call any service and send result to the chat too, please. So let's start. So waiting for your screen in chat. So guys, we wait, I think 1 or 2 minutes more, and after it we will start study simulator. Okay, thank you, Mustafa. Thank you, Jacques.
And one more important thing about topics for you is you have a list of video topics that are available on the browser. So if you open a Mozilla Firefox here on the desktop and type the address local host 8080, and here we have multiple image topics available for us to see. For example, image raw, it is a video stream from camera. If we take off, we can see the change in picture. So yeah, this is the taking off. And the drone is flying over here. This is the image. Also, we have Aruku detect debug, which is how the drone recognizes Aruku markers. There's also optical flow debug. Optical flow is the system for determining the drone's change in position that works without markers. So you can use optical flow even without Aruku marker field. And there is Aruku map image, but you better click on the snapshot here. It is a map of markers that is available for us. And the last one is Aruku map debug, which is basically the same as Aruku markers, but it also builds the frame of reference from here, the X and Y coordinates. And for example, if we go anywhere else, you will see which number and in which marker is assigned to. So this is the marker 90, which is here. And those are image topics that are available for you when the drone is running. But I do not recommend you opening these topics from terminal. It will cause a lot of troubles for you because the information flow is so high. You will be overwhelmed with data and the terminal will break. So do not echo these topics. Okay, this is it for topics for now, and now we can continue with a new thing to learn, which is how do you change the environment, how do you add objects on the scene, how do you edit them. And let's begin. Are you ready, guys? Tell me if you are. Oh, you want the link for entering this?
А я написала в чат.
So the link is already there, and now we can continue with editing the environment. So for example, if I want to add some object on the scene, I can do a few things. The easiest way to do it is clicking some of these three objects, and you can put them like this. And as you can see, the drone did bump up because it recognized that the distance under it was changed, and it adjusted its height according to this distance. And I can land on this cube. If I write commander land in the gazebo terminal, the drone did land on the cube. But this is not the best way to put objects on the scene, because this is standard. It can cause some troubles for you later. And we want to edit and create custom objects. Oh, as you can see, the drone is trying to move this cube, and it will eventually. But what I will do now, I will pause the simulation. So this way you can pause the simulation. And let's enter the model editor. Go to Edit, Model Editor. And this is a better way to create models. Let's build something pretty simple. I'll take a box. And let's create a column out of this box. So I choose the tool for scaling, scale model, and I will reduce the width of this cube. I can increase the height, and now it looks like a column. Now let's copy this one. I pressed Ctrl+C and Ctrl+V. I can move it with my mouse. And we can add a horizontal bar as well. If I press Ctrl+V again and choose the rotation tool, I hold Control to keep it horizontal. And this is our horizontal bar that we will put on top of this model. This is not a 3D editor, so Gazebo is just a simulator. It is pretty basic and not very powerful compared to something like Blender or 3D Max or something like that. If you want, you can even import models from these softwares. Okay, this is, it looks like a gate now, but we will need to make some changes to it. Let's first let's say this model is static, that it's not affected by physics. So whenever a drone hits this model, it will not break. So the model now is static. You can also edit the properties of each component by right-clicking on them and open link inspector. And here you can find pose of the subject, where it is located, and you can even change the color. Let's change the color to make it red. So the color is changing here. Let's increase the RL value in ambient and in diffuse. It's now reddish, but not entirely red, so you can decrease all the other values for green and blue, and over here as well. And okay, it will change the color once we exit the editor. It will be a little bit brighter. And let's see what we've got. So you can save this model. I'll call it gate 1. And now we can exit model editor. And this is our model. You can select this model and move it around the scene anywhere you want. You can also insert it here. Use the gate 1 that I've just made. I also made previous versions a couple of days ago. I will not use them. So if I select gate 1 from here, as you can see, it did. It's not located properly, so I can select it and move it up. Oh, and it is actually pretty tall. It's taller than I thought, because the bars increased its height even underground. I accidentally moved the floor, so I need to change this tool to be able to do this. And you can put as many gates on your scene as you want. And let's try to run the simulation. Yeah, it didn't break, because sometimes after you enter the editor, the simulation stops performing, and you'll need to restart Gazebo. But now it didn't. So you can take off again. At least if the drone will get unstuck. Maybe I should just delete this object. All right, I deleted this object, and the drone doesn't want to do anything. I'll have to restart it. But first, before I restart, I want to save this scene, and I will show you how to do it properly. So in order to save the scene, you need to delete the drone from your scene, because it will also save this, which is what we do not want. So select the drone and press delete. Now you do not have a drone. And this is the scene with our gates. I can go ahead and file save world as, and for example, in home, I will call it my MW, which is my world dot world. Save. All right, it's saved the world. We just saved the world. Okay, let's exit the Gazebo. And what do we do to actually open it? Well, it's not going to be so easy, because the standard world is located in a folder which is home, /AWS, src, Clover simulation, resources, worlds. And the world we are using now is called Clover Aruko. And I will have to replace this world with our world. So let's rename it. I'll copy this name and change it to something like _Clover Aruko. Rename. And I will put my newly created world into this folder and rename it to cloveraruko.world. All right. I think you will need to use this path. Just remember where it is located. It's home, Clover, /AWS, src, Clover simulation, resources, worlds. And now let's go ahead and open up the Gazebo again. Okay, and now we can see that the world is saved with all the models that we've put previously. And this is how you actually put models in Gazebo. The next thing we want to do is edit model. For example, I see that this bar is not in the place. I want to change its position. I can click my model, right click, and edit model. Now I'm in the editor again. I can select this bar and move it to the right position. And now I can say File, Save, or I can even exit model editor and save and exit. Save, save. And now the model has changed. Let's see. The other model hasn't changed, but we can delete this model and insert one more, which is already correct. Okay. This is how you create your model. Do you follow my steps, or you just watch the stream? Can you write if you have done the same already? Oh, just watching. Okay. You will now train yourself to do it. So the next task for you is to create something like that. Let's see the task. Yes, Julia will show you.
So let's try to make it by yourself, and we have a picture of little Sten on the screen now, and let's try to create it in a simulator, in your simulators, and we will make it with you step by step. But you should repeat all action and try to create the same scene and send result to chat. And I hope you can make it. And if you have any questions, you can ask us in real time when we create this scene, and you can say just stop, I don't understand, repeat please. So let's try. So Timofey, now I will send this picture to your Telegram chat, and after it we will open our Gazebo Simulator 2 and start create this scene, and please make it in your simulators too.
Okay, you see my screen. And this is the scene that we just created. I will delete the object that I don't want to have, but this one will stay the same, so I will not change it. I hope you remember how to create it on your own. But for now, I will create another model called maybe pillar or something like that. Yes, so I press edit and model editor. Then I select a cube I put it on the scene and select this tool. The fourth tool, which is scale model. And I'll scale it down a little bit. Yes, you need to do it in your simulator. As you can see, it scales underground as well as up. So when you create this model, make sure you put it up from the ground. And this is what you need to do yourselves. Write us in the chat when you're ready with this and when I can proceed to the next step.
If somebody have problems with editing, please say it and we can repeat all it.
Yes, I have some problem. I, I already insert the shapes, but somehow my simulator gazebo uh, is hang. I cannot move anything.
Well, I think if it doesn't go well, you will need to restart it. Sometimes it happens, maybe when the computer is slow, but I think it may happen on any computer, so just restart Gazebo if it hangs.
Just restart the gazebo or the virtual machine.
Only Gazebo. For those of you who want to proceed to the next step, don't forget that you need to enter Model tab and hit Static. Model tab and Static for those of you who made a pillar. If you saved it without static ticked, you need to edit this model and tick static.
somebody finished or not?
If all of you has done what I just done, I can continue. Or if someone has problems, just tell us and we will help you with them. Well, if nobody is telling that they have problems, I think everyone has done what I just did. And let's then save this model file save. I'll call it column and save file exit modulator. Okay, and this column is on my scene. I can move it wherever I need to. It's better to put it not on the marker but in between. Okay, and I can insert some other columns where we want to. I'll put them up later. Сколько их там должно быть? And let's move them up. All right, and now you can save this world file. So to save, did everyone put all their columns on the scene?
So we have some questions in chat. Mustafa, we need create two models. The first one is gate, and the second one is column. So guys, please write to the chat who finished this task. I saw Ghazali have some problem with gazebo, unfortunately, but nobody knows there. Write it to the chat about their success. Please write plus if you finish, or plus or minus if you have problems with it. Mustafa, okay, I see. Can you send a picture to the chat, please? Maybe somebody else already finished. Bruna, Muhammad, Marcus, how are you? Oh, great, Mustafa. So while we waiting for everybody finished, you can just write a little program for this obstacles, and you can fly through these obstacles if you finish. So, and Timofey said you should save this one, and he will show it now.
Yeah, just before you fly, make sure you save this world in order to not lose any changes. If you have saved the models, they will stay there even after you restart the gazebo. But what if you want to? But if you will close it right now, it will lose all the model positions. So you need to save the world without Clover. Select Clover and press delete. Then you have a clear world that you can save. And let's do it the way, a little bit other way than previous one. I will save it as the same file as we open. So go to Katkinway, WS, SRC, Clover simulation, resources, worlds, and select Clover Aruka.world. And now press save and replace. All right. This way we will not need to move our files anymore. So just you can close the gazebo, and after we close it, you can open it again. Okay, and you can see that the world has opened with the same models in place. For those of you who didn't follow me, I will show it again. So you have all the objects on the scene. You press Clover, hit delete. Now you do not have Clover. And now you need to go File, Save, World As. And here we will go to the Catkin WS, SRC, Clover, Clover Simulation, Resources, and Worlds, and then select Clover Aruko.world.
So Stoddam, congratulations, good job. And how do you think? Will you ready to continue after 5 or 10 minutes? Please write to the chat who ready, and if you're ready, continue after 5 or 10 minutes. If you have some problems with your gazebo now, don't worry. You can just repeat it after this lesson, because you have all videos, and you can try it after it. Don't worry if you have some problem with the computer.
I already checked with my computer task manager, and I found that my memory consumption is already maximum. Maybe because my laptops is not enough RAM or something, and Microsoft Teams and the VMware consume most of the CPU and memory usage. So that's why I think my uh, simulator crashed.
Yeah, it's possible, and you can restart your computer maybe and close all the programs you don't need. But you can do it later while all the videos are still available. After our lesson, it's only 1 hour and 20 minutes left.
All right. As long as the video, recorded video available, then I guess I can follow the video again.
Yes.
So we have a mathematical task now. Forget coordinates of your objects. You should measure. You should calculate it by yourself, and let's try to make it with gaps, for example. And after it, we give you 10 minutes to coffee break. And I hope you relax a little bit. So let's try to calculate coordinates now. We know size of our Aruka markers. Yes, we know, Timothy?
We know, but we know the distances between them.
Yeah, we know, and size and distances.
Yes, we know.
Can you tell me it, please?
The distance between the middle parts of markers is 1 meter exactly.
Okay, and I will send it to the chat. Distance between
Centers.
So we know distance between centers of markers, and now we need to calculate gap position. So in our field, it is
Well, the x-axis is to the right.
1 meter by x axis, and 2 meters by y axis. And if you want fly through the gap, you should give your drone coordinate, for example, 1 and 3 and 1 meters. And it is only in our gap. In your gap, it will different. And 2 or 3 meters. Okay. It can be 2 or 3 meters by y coordinates. So for our field, it is 1, and we can take 1 or 2 or 3 meters by y coordinates and 1 meters by z.
But the drone will hit this bar when it flies towards this point. It will hit the red bar. If you go from here to there, it will hit.
Yes, at
So it
first
need to go here.
Yes. At first action, I should fly to coordinate 1, 0, by y. By y. So this coordinates for our field, but for your field it will in other coordinates. Please calculate it, and after coffee break we can try to fly through this gap and throw your columns. When you finish calculate it, please write plus to the chat. Yes, and we have another easy way to get any obstacle position and any object position. You can just press on the object, and at the left side you have link pause, and there you can X, Y, and Z positions there too. So, but be careful. It just coordinates of your object. It's not the same coordinates where you should to fly, because if you will fly to these coordinates, you just crash your object.
So if you want to edit your model, what you do is click the model, right click and edit model. Then you can make it wider or anything you want. After you edit it, you can file and save, or just file and exit the model editor, then save and exit, or don't save and exit, or cancel. I will not save, I just hit don't save, but you can press save. If it doesn't work in your case, you can restart Gazebo.
So I hope everybody finished to calculate coordinates of your objects. If somebody have problems with gazebo, you can try to reload it, or you reload your computer in coffee break time and start it again. And if it doesn't work, don't worry, you will try it after lesson. So now you have 10 minutes for coffee break, and after it we will try fly through these obstacles, and after we will show you some another things like maybe rangefinder, and maybe how to create Aruka map. So have a good breakfast time. See you in 10 minutes. So, guys, let's continue. If you there, please write plus to the chat or say something. So let's try to write program for flight through the subjects. And the first one, what I need um, to understand the coordinates where my drone should fly. The first one, it should take off from this point, and after it, I should fly to this points and fly through gap. After it, I will fly by line through these gaps step by step, and after it, land. Let's try to write it. The first one, I copy all libraries and proxy to services from Gitbook. I think I open it with code because it's more comfortable to use. So after it, I should take off. So the first point will point near the gap, it is I should fly to there, because if I will fly from start point to the gap, I can touch it, and I shouldn't break it. So I should first fly to this point. It will be near 1 meter by x axis and 0 by y axis. The first one, it is 1 meter by x and 0 by y, and I think it will be 1 meter enough by z, and 0 will arrow come up. You can use body actually, but it is not so comfortable to use, because you can give real coordinates. So it was first point. Second point will I think 1 meter by x and 2 meters by y axis. And there enough 1 meters by z coordinate. And the next point will point between these columns. I think I should make like with gaps and fly to this point before I fly through columns. It will 2 and 2 by x and by y coordinates. And the next one will 0 by x and 2 by y coordinate, and it will be there. The next one will be 3 by x and 0 by y. The next one will 3 by x and 2 by y, and the next one will 4 by x and 2 by y. I think yes. And the last one is will 0 by x and 4 and 4 by x and 0 by y. So I think that's all. I can land, and I think I can make speed more. So let's check it. Oh, I'm sorry, I have a little error. Что такое? Все снимается. So I will restart it. I will restart it. So sometimes you can have some problems with your simulator, so the best way how to fix it, just restart it. So I have two ways how to back it to the start point. The first one is write a little program and come back it to the start point. The second one, and it is easy, just restart it. So let's try again. And landing. So that's all. It is the same like you will have tomorrow task in your competition, and I hope it will easy for you. So now we can continue and discuss how to create a Ruka map, I think, because when you preparing to any competition and our skills Of course, you will make it not only in simulator, and you will make it on real drones in a real flight zone. And you should understand how to create a Ruka map and how to print it and how set up it for the drone. And let's discuss it. I think we should to start from Aruka markers. The first. That's enough. Only one Aruka markers to keep position. And if you should just check your drone is autonomous, and if can your drone keep his position or not, it will enough only one marker. And if you want create this marker, you can use any generator, for example, maybe like this, for example. We use 4x4 markers, so we have 4 pixels on 4 pixels inside, and we can write marker ID. I like number 8 because it looks like a fish. So, and there you can write the size in millimeters. So if you want fly on the height, maybe from 1 to 3 meters, you should use markers maybe from 30 to 35 centimeters. So there I will write 330 millimeters, and it will be 33 centimeters. And there I can save it. I can save it in different formats. I can save it like SVG, or I can open it to save it in PDF like this. And I can print it on any printer, but you need to remember you can use markers only if it hasn't any blinks, because if you have a lot light in your rooms, sometimes your paper and your markers can give blinks and reflections.
They shouldn't be reflective.
Yes, and the system will not work stable. So that is the first way how to create real marker. The second way, it is generator for full field. For example, you can make it in Gitbook. I think we have it. No, we have it only in Russian version. I sent it this link yesterday, so you can create full field there. It doesn't work anymore. Looks like that. So I think it is wrong way. It doesn't work anymore. But we have another way. because you set up your Aruka map in Clover image, and you can see it in these topics in this topics list. And if you open Aruka map image, you can see all field there, and you can copy it from this picture. Just save it to your computer. That is two ways, but if you want to create a really good field, I think you should to use maybe some programs for working with graphics, with vector graphics, maybe like maybe CorelDRAW. You can create the good Aruka field there and use it for real drawing. And now Timofey tell you how create it in the image and how load it to the gazebo and use it there. Timofey.
All right, I will talk from Julia's. Okay. Well, what we want to do here, for example, we want to change this Aruka field to the custom one. Well, there are a few steps that you have to take to create a new field, and it isn't very easy. So just watch carefully, and you can try to follow my steps, but I think it's better for you to just look at again. And let's go to the Clover Correct stack and find the article called Map-Based Navigation. So here you can see that there's an article that describes how you can create a custom map. But before that, it shows you how to enable Aruka marker detection. It is already enabled in this particular setup, but it might not be enabled by default. So you need to make sure that you follow these steps. But we need to proceed to the marker map definition. And it says that map is defined as a text file. Each line has the following format. Let's go to this file, and I will show you what exactly it means. Captain WS, SRC, Clover, Aruka pose, map. All right, and we right now have this map. It's called smith.txt, and let me better open it in Visual Studio Code. So this map contains multiple lines. Each line represents each marker. And as you can see, there are 100 lines. The last line is for the marker 99. The first line is for the marker 0. So for the marker 0. And each number represents some value. Let's see what does it represent. First is marker ID, which is 0 in this case. Then marker size in meters is 0.33 meters. Then X position and Y position and Z position on the field. So X is 0, Y is 9, and Z is 0. Actually, Z is 0 on each one of them because this marker field is flat. But you're not limited to flat surface. You can make you can put markers even on some height. The last 3 digits numbers, they represent rotation across each axis. So first is the rotation along Z axis, which is what you need to change if you want to rotate markers on the floor. The last ones will rotate markers, like put them on each side. You don't want to change them if the markers are flat. And you can generate these TXT files with a built-in generator. It is pretty easy if you understand how it works. Let's go to the article again. Yeah, so this is the command for generating the marker field. Let's generate another one. To do this, we need to write in the console force runner compose genmap.py. Then instead of these variables, we will put some values in it. Here, it even replaced with values in the later part. Then this symbol means that we will put the result of this program into a file. This is the path to the file, newly created file. And the new map will be called testmap.txt. You can change the name right here if you want. Just for the purpose of example, I will copy this comment and I will explain for you what you can change to make your own Aruku marker field the way you want. Let's open the terminal, just a normal terminal, and paste this comment. Don't press enter just yet, and I will describe you what this means. So length, first value is length. It's the length of a side of a marker. So if you look at the marker field, the length is actually the distance from here to here, from one corner to another corner, black on the black square. And the length is set in meters, so always remember it. It's 0.33 meters in this case. Then we have two numbers, which is 2 and 4 in our case. This represents the number of rows and columns. So X is the marker count along the x-axis, which is how many columns do we have, and Y is the number of Y axis markers. So to show you, I will open a image topic list, and here, so you see this x-axis and y-axis. The first of these two numbers is x. So here, if we want to create a map like this, we will have to provide 10 by x, because it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 10 markers along the x-axis, and we need also to provide 10 by y, 1, 2, 3, 4, 5, 10. So these two values have to be 10 and 10. But we can create a custom map, maybe containing 20, or let's do just 5. Let's go with 5 by 5. And it will create a map half the size of what we have now. Then two values is distance between centers of markers by the x-axis and the distance between markers by the y-axis. Let me explain you a little bit more. So the distance is not this white space, but it's this distance from center here to center here. So if it's 1, then it means each new marker is exactly on 1 meter on the coordinates grid. So 0, 1, 2, and so on. If we put 50 centimeters, which is 0.5, the markers will be distributed more closely to each other, but we don't really need it for now. Sometimes you need to place your markers closer, sometimes more further away. So let's keep it 1 in our example. And the last number is 0, and it actually means that the first marker in this grid will have the number of 0. The value of the first marker, which is top left, is 0, and the others will go up like 0, 1, 3, 4, 5, 6, 7, 8, 9, 10. I mean 9, and this 10, 11, and so on. So this is 0, this is 9, this is 90, this is 99. Don't misunderstand it, because some people confuse the marker 0, the marker with number 0. They confuse it with the 0 point on the coordinates, which is not right. So 0 on the coordinates is here and not here. Just make sure you understand. The next, what we can provide here is the name of our file. Let's keep it default, testmap.txt, and I hit enter. Well, it should have created a new field, test map. So this is it. We can open it and see what's inside. It contains like 26 lines, and the first line is actually commented, so it isn't used in the code. It's just for you to understand which value represent which number represent which value. All right, now we can use this map and set up the drone parameters to use this map as a reference. How to do this? Let's go to the other directory. It's got WS, src clover launch, and open aruco.launch. In this file, there are settings for Aruco marker field. In the new drone, you will have to enable these two parameters. They are disabled by default. But we are looking for this line, the line called map, and we provide the right name for the map, test.txt. Now we need to save it and close. So the map is now updated, but you will not recognize the difference unless you restart the simulator. So I will restart it right now for you to see how it changed. But the drone will not fly right now because we have a different marker field in the gazebo. It didn't update, it only updated in drone's memory. So when I run the gazebo, it's still the same field, but if I go to localhost, you can see that this field has changed. This is a newly created field that's in the drone. If you try to fly like that, it will be just not correct. Well, we can try to do this, but you will see that it's not the way you want. Let's run our program. Which one was this?
It's for flying through the obstacles.
Okay, let's run this program and see if the drone does what we want. But it shouldn't actually. It shouldn't do that. All right, it takes off. And it cannot find where it is because it just doesn't see the right markers. It just doesn't fly. So as you can see, we just broke the simulator. Yes, I can. Let's run it again, and I will open the recognition. Aruka detect debug. So it detects Aruka markers, but when you go to Aruka map debug, it detects markers, but they are not. There is no coordinate system. You remember there was a coordinate system from here, which is not present. So it can recognize markers, but these markers are not in its memory. So if you look at the file that we just edited, there is no the marker with ID 90. So just keep in mind. For now, we can stop the simulation and start editing the field on the gazebo. For that, we need to download the generator for gazebo. To do this, I think I've sent you the link. Yesterday. Let me find this link. All right, I found this link. I will send it again. So Julia did send it to you. All right, so let's open this link up. Aruka generator for gazebo. So there is a description how to use it and how to hack it. We will hack this generator. It is still work in progress, so it might change sometime later. But we need to clone this on our Linux. So let's go to the terminal, make sure you are in the home directory, and write git clone, and Control-Shift-V, the link to this generator. As you can see, now we have a new folder, Aruka Gazebo Gen, and it contains of generator.py, readme, and templates. Templates is what the program is taking the reference from. There is a reference model config and world template and some materials and so on. But what we need to do is we need to replace this world template by by our world that we want to put markers in. So let's do just that. I will open up home, Katkin WS, SRC, Clover simulation, resources, worlds. And I will use a Clover world as a reference because it is empty and it doesn't have markers in it. Let me make sure it is empty. So this is the description of world. So yeah, this just doesn't have anything except for sun and parquet. Okay. In this file, we need to add a line. Let's do it this way. First, I will copy this clover.world and I will put it in the arco.gazebo/templates. Paste. So clover.world. And I will delete the word template.world, which is not correct. And I will rename this world to world template. All right, rename world template.world. Now I will edit it with Visual Studio Code. And what we need to do here is, let's see in the article, hacking. We need to include this line model inclusions into this place. So you see world name default, then $model inclusions. Copy that. And after this line, model inclusions and Control S. Okay. Now we can close this world file. And we can go back to the previous directory, arco.gazebo again. I will right click on the white space and open terminal here. So we have opened the terminal in this directory. So we can run generator.py. And now let's run. Python 3 space /generator.py space white space, and now we need to provide the path to the map that we just created. This map was, you remember, in Catkin WS SRC Clover Compose map, and it's called test map. And I will just drag it onto this window. I'll activate this terminal and hit enter. And the script just worked. We have multiple folders created. Each one represents each marker. And I will need to move these folders to another folder. How do I find where to move it? Let's go to home and type here the path. There's a hidden folder that we need to open. It's called .gazebo and the models. If there's no models folder, you can create it. Here in models, I will drag all these markers except for files. I accidentally put templates here, which is not correct. I will put templates back. Okay, so Arco, and it's Arco 0 to 24. Okay, and now I need to, there is also a newly created file, arcoworld.world, which is, we can find what is inside it. It has inclusions of Arco 0, 1, and 2, and so on. So instead of model inclusions line, it included these multiple lines. And these lines include models in the world. So this file needs to be renamed, and we need to put it instead of clover.world. So I will delete clover.world, and put aruco_world.world back to this folder and rename it to clover.world. And now we can try our new map. Let's minimize all the windows in case we need to change anything else, and run gazebo px4. I think it will not load up our model right now because I forgot to change the name. It has to be named actually Aruco World instead of Clover World. So let's close it and rename it again. So where is the worlds? Yeah, worlds. You see Clover Aruco. I will rename it like 2. And this Clover.world needs to be Aruco. Clover Aruco. Okay, now we can run the simulation. And we can see our small new Aruco field. It is here, and the program will actually work on this field because the coordinates are still the same, and it has all these coordinates. If you will run this program, the drone will take off and fly. So the program is independent from the Aruco mapper field. And I think this is it for today. This is the last thing we wanted to give you and have time to give you on this course. Now we can proceed to Julia and Svetlana. They will tell you the latest word.
You think that create objects on the polygon was very hard? Then no, create Aruca map more hard. So now I think we discuss our tomorrow's competition task again, and after it, Svetlana tell us some words. Sveta, can you open? I can open by myself, I think.
Okay, you can.
I want to share final task. 1 minute. So, can you see my screen? Yes. Again, about tomorrow's competition task. You will have your simulator. I think you shouldn't to try change your Aruco map today, because if you broke your world today, it will be not so good for tomorrow's competition. So I recommend you to try change Aruca map and change Aruca world only after this course and after tomorrow maybe. So what about task for today? I tell it again. You just need to create 2 objects. It is ladder and it is landing box. And you should write program when your drone can fly through all ladders levels, and after it land to the landing box. If you feel power programming power in yourself, you can write flip code for flip before you land your drone. So I think that is clear and easy, and I hope it will easy for you tomorrow. And all you is teams of one people, I think, or maybe some people from some countries works together. If it is so, please write to the chat your team's members, and we will understand who in your team. So that's all, I think. Svetlana.
Okay. Thanks, Yulia. Thank you, Timofey. So I sharing my screen.
Hello.
Okay. Hey guys,
Yeah.
how are you?
I'm fine. I'm enjoying it. Yeah. I'm very happy to be part, and I think tomorrow I want to ask permission tomorrow so that I let some students come to observe from the university.
So it was difficult or no?
Yeah, I said I will let some students from the university come to observe.
Okay, it's great. So how it was for them to observe?
Yeah, tomorrow so that they will see and start thinking of how they go into
Okay.
So probably tomorrow you'll get more people. It's 7 o'clock tomorrow, isn't it?
Yeah, great. 7 o'clock.
Okay.
Your day will start from drones, of course.
Yeah, in Ghana. Yeah, in Ghana. Okay, Ghazali.
Ghazali, how are you?
Yeah.
How was your day today?
Today is okay, but unfortunately my laptop is not performing, so I can only watch. But what I think about today is what has been taught is quite clear, and I hope you can upload the recorded video with the good quality so that we can learn it back. And also, I think what we learned today is doable. I mean, we can do it, but it requires maybe some time to make some practice, and then I think you can master it.
Yeah, I'm totally agree with you because this new knowledge takes more time for practice and for self-practice, of course. And that is why we have a great opportunity for video recording. Yeah, and yes, of course, and it helps to repeat all steps after the camp. And sometimes we give you more information than you can understand at the same time. This information you can repeat after the camp using the videos, of course. And all video recordings we will share on our YouTube, and I have shared all links in the pinned message. You can check it. Yeah, and also I would like to ask you to fill the form of reflection because I shared the link again because it's very important for us. We see about your problems, and we try to solve it. And also after the camp, I will share with you full full feedback form. It will be consist several questions about future activities, about your plans, about some information, and it should be to fill it from your side too, for all of you, of course. Okay, great, guys. Maybe anybody wants to share their impressions of this day? Anybody else?
We have to say thank you for you.
Thank you, Mohammed,
Thank you
too.
all of you guys. Yeah.
Thank you for our team, for Yulia, for Timofey, for this day. Okay. And okay, some information from me. Just a moment. I shared my presentation, of course. Yes. Okay. So let's start our evening brief. So some words about today. Yes, about the next day, about tomorrow, the first part of our training day, we will assessment your final task. It is your homework. This is main task which Yulia told you before, and you will provide demonstration using your screen of laptop. You can use video or simulation as well. Please be preparing before. Yes, it's the first step of our tomorrow days. The next, I will tell you about drone projects, Clover projects, and other activities which you can participate in. And after that, we will discuss some camp, maybe plans for the future. So we provide changing opinions. Next, yes. I would like to tell you about some achievements which you have done. I would like to share with you our groups into Telegram. First of all, it's for basic tech support, chat for tech support. You can join in this chat. This chat for those who have questions, who has basic questions about Clover or industrial drones, open source platform, etc. So next it's another chat. It's advanced level who has a programming skill. You can join to drone code and ask any question about drone development, open source development for autonomous drone, of course. So you can join to this chat, save the links, and we will share it in our group chat too. Okay, so congratulations for you because for this day you achieved advanced level for join to drone code. Okay, next. Yes, reflection on the day. As I told before, don't forget to fill this form. It's reflection on this day. Also, you can leave your feedback for previous day too. Oh. Okay, so I think this all. And don't forget about share your photos with Gazebo challenge. Don't forget about it. And okay, see you tomorrow. maybe if you have any questions, we can discuss it. I see chat. Oh, okay. Yulia, Timofey, what about questions from Mustafa about creating the world? I think you can create the world in your simulation, in your simulation environment.
Is this question in the chat in Telegram?
No. It's in the Teams platform.
Okay, let's see. Yeah, you are going to create this world. We will not provide the world. So it's your job to create it on your own.
One more important thing. Yes, if somebody have a problem with Gazebo and with their computers, you can send your code to check tomorrow to me or to Timofey, and we start it on our computers and send the video to you, or you can check it in real time in Teams platform. So if you have some problem, you can just send code to us, and we start it in simulator.
That mean the codes, the Python file. You mean the Python file?
Yes, just Python file.
And the world file, because we need to design our own, isn't it?
Yes.
Okay.
I think if all of you send us your world files, we just save it on our computers and can change it fast tomorrow.
All right.
Mustafa, especially for you, if you want to create your world, you can perform it such as additional task, of course. So, if we don't have any question, I think we can finish. Okay. So, okay. Thank you very much for your hard work, guys. Thank you for our teachers, Yulia and Timofey. Thank you, Mohammed, for your technical support. Okay, see you tomorrow in 10 o'clock. Bye-bye.